Okay, so carrying on from the last video, we drew our ray diagram for an object here outside of the twice the focal length, the radius of curvature. So this time we're going to draw rapid fire ray diagrams of the remaining, there's four here. There's actually one we're not going to draw. Oh, in fact, we might draw it. We'll put it in there as a special case. This is with the object inside the focal length. So all of these rays, all five positions, you can draw one common ray, which is your parallel light ray that reflects through the focal point. Okay, that is one common light ray that you can always draw, a parallel light ray reflecting through the focal point. And just to try and keep this simple, I'm going to draw each of these rays, instead of going through the focal point and reflecting parallel, I'm going to use the equal angle law to do it. You'll see the progression of the light rays as they go. Okay, remember those patterns we're looking for in the previous video. So first of all, the one that we did last time, I'm just making dots to show where the underneath tip of the arrow would be for each of these situations. And I think I'll draw a different colour for each so you can see. So we'll start off with green. So there's our first ray, and it's going to reflect parallel. So there's our image for the first one. Let's colour code these. There's our object. The second one, we'll stick with our red. So we've got our parallel light ray up the top, and it's going to reflect parallel. We're going to have our equal angle law reflecting parallel, and you can see that there's our image. Not doing a great job with this, but you can do some more if you're not sure and if you need to ask questions. So the nature of that image, it's inverted, it's magnification equals 1, it's exactly the same size, and it's still real. Okay, real light rays. So now we come to our object inside to F, but not inside F. So it's back here. We've got our parallel light ray still. Just getting a little bit hard to see, but we'll have to work really carefully with that. We've got our light ray that will reflect according to the equal angle law, and you can see that those rays, if we just move across a little bit, the original green ray, which was our is it the green ray? Yeah, it's the green ray, which is coming down from the top up here. That would carry on down somewhere here, and our blue ray is slowly converging on it. So it's actually going to create a distant image somewhere over here. This is where the axis could continue, roughly speaking. Okay. So straight away, now that we've got three anyway, you can see that there is a progression of sorts occurring. The first image was here, second image was here, third image out here. The image is getting further and further away. So that tells us that the closer the object gets to the focal point, as object goes to the focal point, the image is going to it's going to infinity, going further away. So, and this is in keeping with our understanding that parallel light rays, which would be light rays coming from infinity, from a very distant object, would reflect to the focal point. So as the object goes to the focal point, this is the reverse situation. The light rays coming off of it from the mirror reflect off to parallel and to infinity. Okay. Anyway, we've got another light ray we can draw. Let's use grey. Might be a little bit. This is the object on the focal point. So we've still got our this light ray that's heading down there, but this time we've got our equal angle law here. It should be going roughly through the focal point, which is there. Now what you'll notice in this situation, okay, I'm going to have to draw the last ray diagram. We've got parallel light rays coming off from the mirror, and parallel light rays never meet, which means there's no image. So there's no image when the object is at the focal point. At focal point. There we go. There's a bit of text. Okay. Now I might just quickly draw the last one on a different axis because this is just a little bit messy, or a lot bit messy. It's a good exercise for you to go away and draw them yourself, so you can see how they work. Okay, so now this time we've got our object inside the focal point, and we're going to have our parallel light ray still reflecting through the focal point, but this time if we take our equal angle law, same distance above as below, we're going to find that our light rays are actually spreading out. So this kind of spreading means that they will never meet. And remember, one of the conditions for an image to be formed is that the light rays meet and crosses. However, because they're converging, that does mean that they would appear to converging, diverging, going apart from each other. It does mean that they appear to come from a point. So we can dot these back to find out where they'd cross over, and this is actually where we would see our image for when the object is inside the focal point. Okay, remember, your eyeballs are somewhere on this side, and you're looking, and the light rays are coming into your eyes, spreading out from a point. So it would seem to you that you're seeing something larger than the object itself, and this is the case if you get a mirror, or what's a classic example? Objects in the rear view mirror may appear closer than they really are, or may appear larger than they really are. Have a look at those signs next time you see it. This is because when you're sitting right up close, you might be seeing objects that are also right up close, and they'll be inside the focal length of the mirror, causing a larger than apparent image, or larger than reality image. Okay. So anyway, the nature of this image, it's obviously enlarged, it's obviously upright, that is not inverted, and it's virtual. Virtual images, again, not made from real light rays. A lot of people struggle with this. It's just what you would appear to see, even though there's no real light rays coming from that position. Okay. Anyway, that's all the ray diagrams. We can go over them in more detail. I think it's good to see some examples in context, because that's really what we've covered so far, is just the mechanics of them, and how to draw them. So it's a little bit harder when you have to actually interpret ray diagrams and interpret a situation to be able to draw ray diagrams. Yeah, we'll see how those go.